Okay, so I'm going to try to give you a little bit of assistance. Some people have come to my office hours and asked for help with this assignment. So what I want to do is a couple examples, and I'll try to avoid these questions down here, which are homework. So I'll make up some different examples. So if you have one of these triangles, okay, and you want to calculate, let's see, 1, 3, 4 is a triangle. Okay, how would you calculate that? So we have 3 rules that we can follow. All right, I'm going to try to move this guy over here. There we go. This is a recursive definition, and what we're going to use is mostly we're going to use this definition right here, this rule, but first we're going to look to see if the first rule applies. If it doesn't, we go to the second rule. The first rule applies every time there's a 0 in the upper corner. The 1 applies if the 1 is in the right corner. If you have a 0 and a 1, like a 0 at the top and a 1 in the right, then the first rule takes priority. Okay? Any other situation, you have to use the third rule, which is the situation we have now. Okay, so all we have to do is follow the little map. There we go. And one little notational convenience you can add, instead of drawing the second triangle like that, if it makes it difficult, you can just put a little line here to indicate the second triangle. It might make your work a little cleaner. So what I'm going to do is I'm going to look and say, okay, this corner number, which is a 3, it gets copied into both of these corners. Alright, this upper corner goes in the little upper corner, so your old upper corner is your new little upper corner. So those are the only ones that get copied directly. This number gets copied directly to here and to here, and this number gets copied directly. All the other numbers, which there's only 2 more numbers, are adjusted. What happens is this number, you subtract 1 and then you put it up here, and then this number down here is subtract 1 and you put it down here. Alright, so that's your new setup. Okay, so hopefully that's helpful to you, and you can think of that rule that way. Okay, there we go. So now how will we continue this process? Right, we can just say, well, then we don't know what 133 is. But we do know there's a special rule for 0, which says, so there's 2 ways to represent this. You can say this is 3 plus triangle 313. And that is a good way to represent it. But this is going to get sloppy if we do something, if we just keep dragging this 3 along. So I prefer to then just do the following. At the next line, I can say, well, what is 133? Well, that is equal to, it's not drawing triangles today. Again, I'm going to copy this 3 here and here, and then the 1 gets copied here. And then what happens? I'm going to take the green arrow, tells me to do this, and the purple arrow tells me to do this. And this is equal to 3 plus triangle 132. And I don't know what triangle 132 is, but I have my special rule that I can follow, that follow the red arrows first, then follow the blue arrow, then follow the green arrow, and then follow the purple arrow. So we are 3 plus triangle 311, but this is a special rule. The rule says that because there's a 1 in this corner, then I just inherit that value. Okay? So this is 6. So this is 3 plus 6, which is 9. And this is 3 plus 9, which is 12. All right? So let me pause this. Okay, so hopefully that will help you figure out how to organize your thoughts. I'll make up another example. Let's see. Oh yeah, I wanted to say that if there's a 1 on the top, something special happens that you should be able to recognize what's going on. And when there's a 2 at the top, something else special happens that you should be able to recognize. The special things that happen if there's a number other than 0, 1, and 2, you probably won't have words to describe it, but you might, because you might be creative, but it won't be a standard math term you're used to. But if it's a 1, there's a standard math term you'll be able to use to figure out what's going on, and if you have a 2 at the top, again, that'll be something you should recognize. So for example, this 3, this thing will be kind of a mess, and you'll just calculate it. This, you'll just calculate it. But these guys, you should be able to make some kind of overarching statement about that, and these ones also. That's a 2, by the way. Okay, let me do another example for you. Let me put a 2 at the top. Let me do something like that. Okay, so I can't use the first rule or the second rule because this is not a 0, this is not a 1. So I will use the third rule. And again, I will use the arrows to help organize my work. I will use the red arrows. And then what color did I make the other one? I made it the blue arrow. And then green arrow. And purple arrow. Goes from here to here. Okay, then you just follow the arrows, put the 7 and the 7. The 1 goes here, the 2 goes here, 2 minus 1 is 1. Okay, but we don't have a little shortcut for representing what is happening here. If you do know, you can do like, you can pull off the 7, but only if you know the right language to do it. So let's say we don't know what's going on. So what we can do is we can just say, alright, I'm going to pull this thing aside first, and I can simplify this because this is a special rule. If there's a 1 in the right corner, I inherit the 7, and that's the value of the whole thing. Okay? And so what I'm going to do then is, this is a little harder to write, I'm going to push that down below here. Because this whole piece is 7, then I can rewrite this as 177, and then what I can do is I can pull it off to another piece of paper and calculate the 177. So we just showed that this triangle that has 722 has to be the same as the triangle 717. Okay, now we got to figure that out. So something you should realize is that it's really important to decrease this value in the upper part of the triangle. Okay, and it will happen naturally. The formula will just make it happen for you. But notice that if there's a 1 up here, then at the next stage you're going to get a 0 at the top. And zeros are easy because we know it's some kind of addition going on. So what do we do? This 1 comes here, this 7 becomes a 6. Okay, and then what does that mean? It means 7 plus 1 and 7, 6. Okay? So I'm going to leave room to put the answer here, but let's just figure out what is 176. Well, 176, get the 0 at the top, the 2 7s, the 6 becomes a 5, the 1 stays as a 1, so that's 7 plus the old triangle. And if you understand what's going on, you can fast forward through the video, but if you don't, you can just watch me do this. Okay, and so this is going to be 7 plus 174. If you think this looks like a pattern is forming, you're right, but it's up to you to actually figure out what the pattern is and what it means, what's actually going on. Okay, and if you understand this, you can shortcut it a little bit by doing this. Aha, we finally got the one in the right hand corner. Okay, so the way you backtrack this is now I'm going to write in red all the stuff that you write after the fact. Okay, since we know that this guy is 14, then we just write 7 plus 14 is 21. 7 plus 21 is 28. 7 plus 28, 35. 7 plus 35 is 42. And 7 plus 42 equals 49. So this guy is 49. So this guy is 49. Okay? And so that's how you unravel these guys, just one step at a time, very systematically, very methodically. And eventually, what I'm expecting is you should be able to tell me the following. What does it mean? Can you give me a math expression that tells me what that does all the time? Can you give me a mathematical expression that tells me what this does all the time? So we already know from the rule the rule is over here. We already know from the rule if there's a 0 at the top, then we're adding the other two corners. Do you have enough clues to figure out what is going on when there's a 1 in the upper corner and what is going on when there's a 2 in the upper corner? It's not addition, but it's something else you have a name for. Both of these are things you have names for. And this one, you might have a verbal explanation, but you don't have mathematical language to describe 3 and up. You won't have the language, okay? But these ones you will. And so those are things that should come out in your write-up. Okay, hopefully that's helpful. Please stop by and see me if you have questions.